I have a question. Okay, it has been started anyway. So, welcome everyone. I'm Yevhen Nadashkivsky, L&D manager in All Stars IT, also Microsoft MVP in data platform category. Today with us another Microsoft MVP, but in Azure. It's Anton Boyko, who is actually a founder of Azure Cloud Community in Ukraine. Also, he's like the most frequent speaker. Uh, he's Microsoft regional director as well. By the way, Sergey, may I ask you to mute yourself, or somebody who has admin rights? Yeah, thanks. Anton has been working in IT, I don't know, for more than 15 years, I suppose. And I know him as a cloud architect, but he may take a lot of positions. He's like CTO and a full stack developer as well. So he can handle a big project single-handedly. But today, with the support of All Stars IT, the company that gathered us today, we will be talking about documentation as a code. Like, documentation is always a big deal for us. I think most of the projects lack documentation. Plus, writing documentation is a big pain because it requires additional time, and we always have no time even to finish our coding, not to mention some documentation. There are special people who usually write it for clients. Those are technical writers, but if we are talking about code documentation, database structure documentation, like projects in general, like architecture schemes, like different types of diagrams, I rarely see these in startups, but all the mature projects, they do require documentation, and at some particular stage of growth, documentation is mandatory because you start to spend too much time on teaching others than on coding itself. So let's thank Anton. Let's thank All Stars IT. By the way, All Stars IT is international IT company. It's outsourcing, outstaffing company that was founded in Israel with headquarters in Warsaw. We have Ukrainian, Israeli, Polish, Czech, Austrian, basically most of the European Union countries are covered. Also America and even South America, Colombia, for example. If you have any friends from Colombia who are working, who are looking for work, you may join All Stars IT. And there are a lot of open positions, but we'll get back to it at the end. At this moment, I want to thank everyone who has joined. I want to thank All Stars IT, and I want to thank Anton Boyko and give him the word. Anton, thank you. Let's start.
Yep. Thanks, Yevhen, for this introduction. I do believe that we have a good material for a new joke, because one of my other titles specifies that I'm also a Microsoft regional director. And some time ago, the friends were joking and called me Microsoft original director. And you were talking that I speak really a lot. I speak frequently also on All Stars IT meetups. So now we do have another joke that I can also be a most freaky speaker. Anyway, so as it was said already, today I would like to talk about documentation as code. The idea here is that in one of my projects that was quite recent project, that was a really big project, as Yevhen mentioned as well, we struggled a lot because we didn't have almost any documentation, and at those points where we had some documentation, that documentation was outdated. And the outdated documentation is actually even worse than not having the documentation at all, because you're going there, you're trying to read the documentation, try to understand how the project is working, and then you get to the team and the team said, yeah, you know, but this is entirely incorrect. Now this part worked like that, and so on and so forth. So this is an experimental topic. This is the first time I'm presenting this topic to this audience. And I really, really want to encourage you to give me feedback, because I probably will also present this topic a lot on other meetups, and I want to improve that. So yeah, feedback is extremely appreciated. So the disclaimer that all opinions are my own, because today I will be probably talking about some, you know, like some points that may be a good opportunity to have quite a big flame war. So you may agree with me, you may disagree with me. I'm not saying that everything that I will say today is the only one possible way of working. My point here is just to share my experience. Talking a bit about the scope. So there are a lot of different kinds of documentation, and today I would like to talk about the technical documentation only. So technical documentation only, what I'm saying here is that this is the documentation that is created for engineers by engineers. Okay, because in the project we also may have some business documentation, some other kind of documentation. This is out of scope for this topic. So today we will be doing only the geeky stuff, you know, only the technical documentation. So let's actually start with this question. So why do we have poor documentation in the first place? And yeah, I heard a lot of excuses, and I tried to summarize the most, you know, like frequent excuses here on this slide. So first of all, engineers are not used to writing it. So they don't, I mean, like they don't used to it, and they don't know where to start. They don't know what to do. And this is extremely painful. So that is why they don't want to go basically outside the comfort zone, and they don't want to write the documentation. If they can spend their time doing something else, for example, creating some new features for the product and so on and so forth, they will be doing that. And the fun stuff here is that in most of the cases, the project managers, I don't know, like any other business people, they will mostly support this behavior, unless you have pretty, let's say, straightforward architect like myself in your project. In that case, I will be really, really kicking your ass if you will not do the documentation properly. Anyway, so as I was saying, they don't know where to start. This is another issue. So if they are even able to some degree, let's say, convince themselves that, okay, I will spend half of the day or like the whole day today to write some documentation to document my work or document the work of my peers, they don't know where to start. And yeah, this is another issue. This is the issue related more to the, let's say, how to write the good documentation content. But nonetheless, this is also a problem that I will be trying to address in my session today. The reason, I mean, like not the reason, but the impact of this issue is really, really huge, because I mean, like that person can spend, you know, like the whole day trying to understand where to start, and then at the end of the day still produce nothing. And this is actually quite an interesting point as well from another angle, because, you know, everyone likes to read a good documentation, and everyone can more or less define what the good documentation mean. But I mean, like if you know how you can understand that this documentation is good, this documentation is not good, then you probably know some attributes, and by those attributes you understand, okay, this will qualify as a good documentation. But somehow yet you are unable to write it. So this is the really strange phenomena, but unfortunately it is true phenomena. I see that not only in my projects where I'm working with the Ukrainian teams, I see that also in the projects when I'm working with the global teams from Western Europe, from North America, and so on and so forth. Another excuse, why should we write documentation now because the implementation may change, and if the implementation will change, it will mean that we will also need to change the documentation. This is another good excuse, and again, in a lot of cases, this stops the teams from writing the documentation. And another one, it's not an excuse, but this is probably the thing that I notice in each and every project. They were saying that we will create, okay, we know that documentation is important. I'm 100% sure we agree, we're on board, and we will create a separate task in Jira or whatever else, and that task will say something like, write documentation for this feature. Okay, and in that case, in one hand, they are trying to create a task to manage this work, but on the other hand, how it usually happens when we don't have enough time in a sprint or in a scope of the whole project to finish all the actual work, and we're starting to cutting down the scope. So we start to think what we can throw away, and usually the first candidate to throw away is the documentation. So kind of a small learning from this one is that if you will have a separate tasks in your task management system related to writing the documentation, you will never ever actually get to the point of writing the documentation, because those tasks will be always with the lowest possible priority. And what I want to do now, I want to basically try to project that to another topic that was extremely painful for engineers, especially for developers, maybe like 20 years ago or something. To some degree, it's painful even now. But anyway, let's talk about unit tests. 20 years ago, that was not really common to do some test automation. Maybe even like 15 years ago, that was also not common to do some test automation. So when we asked someone to write some unit tests, what we heard from them, engineers not used to writing it. Engineers don't know where to start. What if the implementation will change? It will require to rewrite all unit tests. And also, we will have a separate tasks in our source control, in our task management system to write unit tests. So, I mean, like, I do believe you get my point here. So 20 years ago, that was unit tests. Now, I don't need to go to my teams and explain them why unit tests are important, how to write them, and so on and so forth. They already know that. So by that, basically, I'm really hoping that at some point in time, maybe like in a few years from now, I will not need to go to my teams and also explain them how to write good documentation and why this is important. But another kind of a small point here is that, to some degree, it's really hard to master a new tool, but for the engineers, especially for developers, but I mean, like for engineers in general, it may be hard to master a new tool, but it's relatively easy to master a code. So that is why treating your documentation as a code is a good approach in general, because now you're basically doing the same stuff that you did before. What I was saying about unit tests for a long time, for maybe like 10 years already, is that one of the features of the unit test, one of the super powerful and to some degree kind of a hidden feature of the unit test, is that the unit tests themselves, they serve as the documentation for your implementation. But again, our topic today is a bit broader than the topic of test automation. What I'm saying to you is that you don't need to be afraid, because if you know how to write good unit tests, that this is already can be considered as a part of your documentation. It's definitely not the whole documentation, but at least some small part of it. So the learning number one that we get basically from everything that we discussed already is, or what we should get, is that we need to change our definition of done. We need to change the way of working in the team, in the project, and we need to say that we should have a list of what needs to be done for each feature so that feature can be closed. And the documentation should become a mandatory item on that checklist. So that checklist should look something like this. If you want this feature to be closed, you need to write code, you need to write some tests, and you need to write some documentation. What is interesting here? It's kind of easy, to write the code, to write the tests, and then start the process of code review so the other team members can also review what was done, and they can either accept your pull request, or they, for example, can provide you with some feedbacks and ask to do something more, and so on and so forth. If we are managing our documentation as code, then it will mean that we can do the same with the documentation. We can review the documentation together with reviewing our code, together with reviewing our tests. But we will get to this a bit later. Now I want to talk about this interesting, let's say, angle of working with the documentation, the topic of views and viewpoints. Let me ask you this broad question. So for whom do you believe you create your documentation in the first place? Because if we're talking about the application, then we create our application for our end users. Okay, if we're talking about, for example, test automation, for whom we create test automation, we create that for ourselves. So if I have a lot of tests, then I can be more or less secure that if during the Christmas I will need to do an urgent deployment or something like that, then everything will go smoothly, because a lot of things that can go wrong are already covered with those tests. So the question here is, who will be the consumer of our documentation? And here comes this separation of views and viewpoints, because in terms of the stakeholders, there may be a lot of stakeholders, and this is just a few of them. So first of all, our documentation, it can be useful for the CTO. For example, if we are working on a really big project, if we're trying to, I don't know, like do some digital transformation in the organization or something like that, then the CTO will be one of the stakeholders. He will definitely read what we are about to create, and he will review that and provide his feedback. Also, the chief security officer, the chief operational officer, the architect, your peer developers, the cloud engineers that will need to create an infrastructure in the cloud, for example, and host your application there, the QA engineers, the support engineers, so everyone. My point here, why I'm showing you this list of the stakeholders, is you probably understand that if you will try to create a documentation for each and every person individually, for each and every role, individually, then you will probably spend your entire life for that, and still you will not reach a success. The idea here, what I'm trying to say, the idea here is that all of them, they do have those different viewpoints. The CTO will be interested in one topic, the chief security officer will be interested in another topic, and so on and so forth. But for you, when you are a part of the team who works on that documentation, it's really important that the documentation is consistent across all of those different views and viewpoints. So when we're talking about viewpoints, the viewpoint is dedicated to the role. So the chief technical officer will have his viewpoint, the chief operational officer will have his viewpoint, and so on and so forth. But when we're talking about views, I know that, for example, Mr. Yevgen here, he works a lot with the databases, so he knows what views actually means. He knows what is the difference between views and tables. So the views here makes the same sense as in your relational database. You may have a lot of data stored somewhere across your tables and so on and so forth, but for this particular purpose, you want to get this piece of data, that piece of data, and create a view from that. For the other person, you take some part of the data from the first view, some part of the data from the new table, and create a second view. So my point here is don't, I mean, like literally never, ever try to put everything on one diagram. Don't even try to create that one ring that will rule them all. It will never work. It will never work because that was actually a really funny moment when I joined one of my projects, and I asked my team members that, hey guys, do you have a documentation? And they said, yeah, we do have this awesome diagram on a Confluence. I went there, and yeah, there was a diagram, and that diagram contains more than 100 nodes on it. I mean, like more than 100 nodes and maybe like 200 connections between those nodes. So technically, I was able somehow, you know, like to fit that diagram in one screen, but that diagram was entirely useless because I was unable to read it. I was unable to understand that. So yeah, don't try to do something like that, but try to scope with your views, try to scope the content that is important for those different viewpoints. And yeah, in that case, you will actually reach the success. And we will be talking about that in more details later. What I want to do, I want to check what we have in a chat, because I see a question here, how we can sell these tasks to a customer. The business saying that it's not worth spending money on them. Yeah, this is a really good question. So how we can actually say to our I don't know, like budget owners that they need to invest something to have a good documentation. To be honest, I tried a lot of different approaches, and the approach that works, at least so far, that approach works the best, was the approach of not telling them that we will be working on documentation. This may sound, you know, like kind of backwards, but anyway, so when you are working on a team, when you are working on a project, what they usually ask you what it will cost for us to create this feature. For example, on our website, we want to, I don't know, let's say, replace the search engine from Google search to Bing search or whatever. So this is the business need. They came to you and they asked what it will cost. And you start thinking, okay, so I will need to do some development here. I will need to do some testing there. I will need also to maybe update my documentation. I will need to do this and that. And then you just reply back to them that, hey guys, that will cost you like one pile of money or something like that, like, I don't know, like $100,000 or something like that. If they want to go into details, then you can go into details. But the thing here is
нельзя так делать.
Yeah,
Yulia.
I hear some background noise, and that commentary was extremely, you know, like in a moment. But nonetheless, what I'm trying to say here is that there is a big difference between what you are doing and how you are doing that. Okay. So if they ask you what it will cost, you will reply that it will cost this. If they will ask you how you will be doing that, then you can say, okay, we will have developers here, we will have architects here, we will also need to have like a few quality assurance engineers, and so on and so forth. And if they will try to challenge you, you know, like with something like, yeah, but why do we need like 2 quality assurance engineers? Maybe we can have only 1, and maybe we can have like 0 and just ask developers to write the code without any bugs, and so on and so forth. I mean, like, you know the drill. You probably participated in those conversations a lot. And on that point, I want to get back to this statement, how versus what. So the idea here is that when we are working on our code, I do believe that that was the Uncle Bob who said that, I mean, that was his quote, that when he looks at the code, that code explains a lot about how we are doing stuff. But usually this code, especially, I mean, like he was talking about the bad code, the bad quality code. The bad quality code almost never explains what exactly we are doing. Okay, so we open, I don't know, like we open a file and we see, okay, here we have a loop, here we have some dependency injections, here we have this and that. But I mean, like what we are exactly trying to do? Are we trying to launch a spaceship? Are we trying to create an AI for driving a car? Or I will just try to, I don't know, like book a tickets to the train that will go tomorrow to the next city? So that's why I want to stop a bit and talk on how exactly we can start working with the documentation. There are a few models, and I would like to talk about two of them to you today. So the first model of documenting your code, your project, your solution, called 4+1 view. And again, I will start the explanation backwards. I will start with +1, and then we will explain what 4 stands for. So the +1 stands for scenario. So you always start with a scenario, what you are trying to do in terms of, I don't know, like a business scenario. And then as soon as you define what the business scenario is, then you create a logical view or a logical diagram. The logical diagram, I found that extremely hard for engineers to master. And the reason why logical diagram is extremely hard to master, because the logical diagram should be 100% technology agnostic. So let's say that you're trying to create, again, like an e-commerce website, and the logical diagram will consist of blocks that may look like, okay, here we will have, I don't know, like the product catalog service, like an abstract service. Here we will have a checkout service. Here we will have an abstract payment gateway, and so on and so forth. My point here is that when I'm talking about all of those logical components, I should never talk about technology at all. I should talk only about their business purpose. And when I'm talking about logical components, it's also important to show, because this is actually the top level diagram in this model, this is important to show actually which components are aware about which other components. So let's say that I will need to have, I don't know, like 2 services, okay? I will need to have, for example, a checkout service on my e-commerce website, and I will need to have like a product catalog service. So the question is, will they know about each other? And if they will, then who will know about who? Will it be the product catalog who will know about the checkout, or will it be checkout who know about product catalog? The reason why you need to do that is because in that case, you will be able to really easily understand, do you have any circular dependencies or not? And if you have circular dependencies, then this is actually one of the first markers that your architecture probably was designed wrong, or at least not in the best way. The next diagram that you create the process diagram. So we understand that, okay, now we have this set of logical components. Now on the process diagram, you need to show actually for your scenario, if you need to go through this entire scenario, how the actual process will go. So, for example, let's say that I want to work with this e-commerce shop. In that case, the process diagram may look like following. So when I'm trying to put an order, okay, what it will do, first of all, it will call a service to calculate the price for the order. Then when I will get back the price, I will pass the control to my checkout service, and the checkout service will call a payment gateway. The payment gateway will open me, I don't know, like a new page on a totally different website. I will enter my credit card number there, and then my service will be waiting for the callback. As soon as the callback will get back, my service will change the status of this order to paid and maybe trigger some other process, I don't know, like the delivery system or something like that. So when we're talking about processes here, we are again showing who controls what. So we're showing that this component should call that component, and so on and so forth. Only the third view here in this module called the development or the implementation view. So only at this level, you are able to start talking about the actual technologies. Okay, so now you can ask those kind of questions. Will we do that on C# or Java or Python or whatever? Will we be using, I don't know, like Microsoft SQL database, MongoDB, or whatever? So here, only here, we are talking about the actual implementation. And the last diagram or last view is the infrastructure or the deployment view. So now we need all that stuff to be up and running somewhere. I really hope in the cloud, but even if it's on premise, still you need to show that, for example, I will need to have this compute resource. I will need to have, I don't know, like this many virtual networks. I will need to have a storage of this size. Maybe I will need to have a geo-distributed deployment, and so on and so forth. The big idea in 4+1 view is that you are always working within the scope of the same components. So you defined your components here on the logical view, and then on the process view, you show how those components will interact. On the development view, you basically show what will be the implementation details of those components. And on the infrastructure view, you will show how you actually deploy those. Will you deploy them on top of virtual machines? Will you deploy them, I don't know, like on some kind of an edge devices, and so on and so forth. Let me actually give you an example how it can look. So let's say that we are about to create a website, and what we defined on the logical level, we defined that, okay, we will have two different roles. We will have the user of this website, and we will have the editor of this website, which basically means that we will need to have two logical components, one for content editing and the other for content distribution, which also means that we will need to have a store for content, and also we will probably need to have a store for assets where we will be storing some binary data like images, video files, or whatever. So this is the representation of your logical diagram. Okay, now from logical diagram, you start talking about the development diagram. So I will skip the process view for now. So talking about development, you're saying, okay, so what we will do, we will actually use a WordPress, and then we will probably also write a few plugins on top of the WordPress. The reason why I choose explicitly to use WordPress here is because you see, you have one implementation block, let's say, which covers two of your logical blocks. That's totally fine if that happens. That's perfectly normal. And then you're saying that for the content store, I will be using a database, and for the store for my images and video files, I will just store them somewhere on disk. So now your dev team can start working with the WordPress, can start creating those plugins, and so on and so forth. And then you're talking about the deployment. So how we will deploy all that stuff. And again, I'm assuming that you will deploy that to Azure Cloud. So in that case, you're saying, okay, we will have this Azure VNet, and everything here will be in scope of this Azure VNet. So for the asset store that we decide to store on disk, we will use Azure File Share. For the content store that we decided that will be the database, we will use Azure SQL for MariaDB. For example, the WordPress itself will be hosted on top of Azure Linux Web Apps, and Also, we will be having the Azure Application Gateway, which will help us as a web application firewall. And also we will have the Azure CDN that will help us to cache some static content to improve the performance and so on and so forth. The point here that I wanted to show explicitly is, again, so the WordPress and the disk and the database, those were components that we inherited them from the top level. That's why we specified that we will be implementing them in this and that way. But also we have some specific details that are interesting only for those who will be responsible for the actual infrastructure. Like, for example, how many VNets we will have, how we will split this VNet into subnets. Do we need to have like a single entry point to our infrastructure, and so on and so forth. And again, this is perfectly normal to add those implementation details when you are basically moving further down the line in your implementation details. But if you will check the blue boxes here, the blue boxes, they are related only to business. And from the business perspective, they don't care how many VNets you have. They don't care how exactly you ensure that no one will hack your application. You may have like an application firewall here, or you may just, you know, like create a you write down the code that will be unhackable, let's call it like that. And business also don't care about the CDN. Business wants this application to perform fast. If CDN will help you to reach that goal, fine, but CDN, it's not something that came from the business. So this is my point here, that when you are working on the documentation, this is a really good example on how you can start. This is the really good example how you can basically proceed from top to the bottom. And on each and every level, again, here I was just trying to put everything on one slide, but I do believe that you understand that even for components like Azure File Share and Azure SQL for MariaDB, there may be a lot of details, and potentially this is also quite a good approach, and I was also using that a lot, that you're specifying something on the top level. So you're creating, let's say, the top level deployment diagram that will look like this. And then you're starting to break it down. It's not mandatory that you will have only one deployment diagram or like only one logical diagram. No, you can have as many of them as needed. The other documentation model called the C4, and C4 stands for context, container, component, and code. The idea of this model is more or less the same as 4+1 view, and if I'm not mistaken, the author of this model, he also specified that he was inspired by 4+1 view, but then he created his own model, which is mostly, you know, like focused on the dev side only, because it starts kind of on a context level, so it starts kind of on a business context level, but then it narrows down to the code, and not always we have something in this model that is explicitly related to the infrastructure. So yeah, C4 model, it's also a good model, but what I'm doing in my projects, actually, I'm using both of them. And this is perfectly fine. So I'm always starting with 4+1 view, because 4+1 view can allow me to really fast create that kind of a helicopter view for the project. And then when I'm basically now inviting, let's say, the developers, the cloud engineers, and all the other guys to join me and take over the documentation, I recommend them to use C4 model, because that's much easier for them than to specify all of those details using the C4 model. In most cases, when we're talking about documentation, we will be thinking about some place where we need to host that, and in most cases, we will be using Confluence for that. And the title of my next slide is why Confluence is not working. I should probably add the question mark to this title, but anyway, maybe not even the question mark, maybe the exclamation mark, because this is not a question, this is really a fact. But again, this is my own opinion. So my biggest issue with the Confluence is that the Confluence is disconnected from the code. So when you are working with Confluence, yeah, I mean, like you have a lot of plugins, you have a really good, what you see is what you get editor and so on and so forth. But now you have code in one place and documentation in another place. And it can be really hard to keep track on all of those changes, what was changed, when and for what reason. And yeah, it just adds, at least in my opinion, it adds a lot of unnecessary complication to the process of managing your documentation in the first place. So another one, another point that I also noticed is that when you're working with the Confluence, you are usually focusing a lot on the layout, on the way how you will put all of those different, like blocks on a page, rather than the content of the page itself. And I do believe that to some degree, this is because the Confluence is so popular, because a lot of companies want to be on the Confluence market. They want to create their plugin for the Confluence. And yeah, now we have a million of those plugins. And now, as I was saying again, the focus on the content itself was a bit lost and was shifted more to the focus on how we will exactly structure that. I want to remind you that we are talking today about the technical documentation only, because when I was basically pitching the same for the business users, they were like not at the same page with me at all. And this is perfectly fine. I mean, like I can perfectly understand them, because for the business users, when they're working with different documents and so on and so forth, for them, the solutions or like the tools like Word and Excel, those are the tools that they are using on a daily basis. So that is why Confluence looks really like those tools. So that is why they like it more, because they have this what you see is what you get editor and so on and so forth. So again, for non-technical documentation, Confluence may work, but this is out of scope of our session today. And the last one is, I do believe that Confluence is actually a bit bulky. It requires quite a lot of computer resources to run. It's not always easy to manage, not always easy to update. You should have a separate department that will work on that. I mean, like I usually was facing that in the big companies of about like a few thousand engineers, that for a few thousand engineers, they will have like 2 or 3 people that are dedicated to Confluence only. So yeah, I mean, like this is why me personally, this is why I don't like the Confluence a lot. So, but if not Confluence, what else? Another message in the chat, we will actually get to that topic to answer that question a bit later. But if not Confluence, then what? So the title of the presentation was Documentation as Code. So what we can use to handle documentation as code, we can use the Markdown. I do believe that everyone knows Markdown. Actually, you know what? We can actually check who is listening and also who knows English. So please raise your hand if you know what Markdown is. If you at least once in your life read Markdown or maybe write some Markdown, I just want to see a lot of hands in the chat. Okay, 5, 6. Okay, so I assume that everyone will raise his hand. So the idea here is that if we will work with the Markdown provide us with technically much less features than the Confluence, and this is true. I mean, like I will not reject that, but sometimes less is more. And my point here, again, I want to get back to my previous topic, is that when I'm working with the Markdown, I don't have all those fancy capabilities in terms of how to put my table here and so on and so forth. But I am more focused on the actual content. And authoring the Markdown is actually super easy, especially when you really get to it. But now the other question appears. So I was talking about the different view models and I was showing you different diagrams. So if you're working with the Markdown and Markdown supports only text, then how you can actually work with the diagrams. So we do have the Draw.io, or as also known as diagrams.net. And what you can do with that, you can, for example, create your diagram there. You can export that as a PNG file, and then you can basically put it near your Markdown file, and now you kind of have diagram. Yeah, to some degree that will work. The same will work with Visio as well, but yes, exactly as it was mentioned in a chat, there is a way how you can create your diagrams with text. This is, I mean, like, to some degree, I do believe this is extremely underestimated feature of text in general, because, you know, we do have Git as a source control system. If we are engineers, then Git long time ago already became a standard, and we know how to use Git to use it as a source control engine for our code files. And if we will be using Markdown for documentation, Markdown is text. Diagrams will also be created in a text. So now we have the fully fledged, well-known, well-established platform for versioning our documentation. We will not reinvent the wheel. We will use the technology that we already know. And yeah, diagrams as text, there are actually a lot of tools for that. I mean, like, literally probably at least a few dozens, maybe even up to 100 different ways how you can do that. But today I would like to talk to you about probably two most popular approaches. The one was already mentioned in the chat, the Mermaid approach, and the other one is Plant UML. So let's actually go and check some demo, how it works and why it's so awesome. I hope you can still see my screen. I will need to switch to Visual Studio Code. So this is my Visual Studio Code, and this is the perfect tool for you to work with your documentation. I also assume that if you're a developer, you also know what Visual Studio Code means. This is the free tool, and there are a lot of plugins that help you to write that documentation. So what I want to show you here, I want to show you two pages here. So this is the first page. On this page, I have this mermaid diagram. So this is how it looks like in the text. And then when I will add a few plugins on top of that, what I will be able to do, I will be able to run my preview for the Markdown files in general. And this is the actual graphical representation of this diagram. So I can say that, for example, you know what, I actually need to rename it here. So it needs to be something like Mermaid. Awesome. As you can see, it works like a charm. And the idea here is that, of course, it helps you a lot if you see this picture, but the idea here is that you have that as a text. It will be rendered either locally when you're creating the documentation, or it will be rendered when you're basically be working with the documentation then in a browser. And during the code review itself, it's also relatively easy to see what was changed in that diagram. Of course, feel free to include some text to your documentation as well, but I will not actually spend a lot on how to version text under Git. And the second tool, or like the second way of writing those diagrams, the second rendering engine is Plant UML. Plant UML is a bit different. So what Plant UML can do for us, if we compare that to Mermaid, so the first difference will be in a way how they render those diagrams. Mermaid works 100% on the client side. It renders everything in a browser. It creates a canvas and draw the entire diagram entirely in the browser. For the Plant UML, you actually need to have a server that will get as an input, it will get this definition of your diagram, and then as an output, it will produce a PNG image. But again, that image will be embedded in your browser, it will embed it in your HTML page. So on one hand, you are working with the text, but on the other hand, when you will render and publish the final website, you will see this nice and fancy diagram. And the reason why I'm also actually prefer to use Plant UML, the reason is because you can have much bigger selection of all those different, like controls. Because when you are working with the Mermaid, you have only, like some basic shapes. When you're working with the Plant UML, as you can see, this one looks much more fancy. So yeah, this is actually how you can do that, how you can manage your diagrams as a text, but this is not all. Let's actually get back to the presentation. This is just the beginning. So the thing that I mentioned a few times already, so now we can review our documentation as a part of the regular code review flow. So we create code, we create text, we create documentation in a new branch, then we create a pull request and everyone can review that. And it also includes diagram. So how we can manage now a bunch of markdown files, because in one hand, we know that on a GitHub, it's really kind of a standard that you will create a README file and also maybe some wiki that will describe, for example, how your application works and so on and so forth. And on a GitHub especially, or not on a GitHub, but because of the GitHub, I do believe Markdown became so popular. But how you can actually manage like 1,000 or even millions of those different markdown files that you will have across your repo. Okay, so what you can do, you can use a tool, or not, it's not a tool, actually, it's kind of a category of tools. You can use a static site generator. The purpose of the static site generator is to basically grab your markdown files and from your markdown files generate some HTML. So in this case, your markdown files or your Git repo becomes kind of a database for your documentation system. As soon as something changed in your Git repo, then this tool will run again and it will regenerate all the static pages for you. And there are actually a lot of tools in the market. For example, the most popular tool for static site generation called Jekyll. This is actually the tool that is used by the GitHub itself. It's based on Ruby. Another tool, for example, is Ghost. Another one is Docusaurus. Docusaurus is created by the Facebook. It's based on Node.js and React. And today we will be talking mostly about the Docusaurus tool because among all of them, I actually prefer Docusaurus more. Also, as was mentioned in a chat by the other Yevgen, there is a tool called Backstage. Yes, I know about Backstage, but I don't really actually like Backstage because what I believe that at some point Backstage was more like a static site generator, but then after some point they decided they want to introduce more and more features, and they kind of started moving towards to becoming like a new Confluence. The reason why I prefer Docusaurus because the Docusaurus, at least in my opinion, has this perfect balance of simplicity to amount of features that I need in my projects. Yeah, I mean, like the other question from, or like the other comment, sorry, from Dmitro in the chat, that he usually holds a separate pieces of like the separate files with the Mermaid diagrams, and they are not directly part of his repo. This is actually another topic that we'll be talking about in a few minutes. Another thing that I was kind of, supposed to put here, another static set generator called the Solidify project. I do believe that only maybe like 5 people across the world literally know about this tool. The reason why only 5 people know about this tool, because this is the tool that actually I am an author on that tool, and I created that tool maybe like 5, 6, or 7 years ago, just to get a bit more understanding of how static set generators work in the first place. So the Solidify project, it's available on a GitHub. It has like 2 stars, if I'm not mistaken, from me and the other guy who contributed a bit into this tool, but nonetheless. And there are much more of those. And if we go to the Jamstack website, if I'm not mistaken, this is the name of the website. If we go to Jamstack website, and if we will look for all the static set generators that are now on the market, that will be, if I'm not mistaken, like a few hundreds of them. Some of them are more focused on just general websites. Some are more focused on kind of a blogging functionality. And the Docosaurus here, it's mostly focusing on the documentation, the way how it structures, the way how the new features, how they roll out the new features. It's mostly focused on the documentation. Let me actually show you how it works in real life. We will actually get back to our repo. As you can see, there are a lot of files here. But what I will be talking about, I will be talking mostly about this docs folder. So you can go to docosaurus.io website and grab a simple command on how you can bootstrap your first Docosaurus website in the local folder. But nonetheless, there are some configuration and so on and so forth, but the magic, or like not the magic, but let's say the content, is located under this docs folder. So as you can see here, for example, I have a tutorial subfolder. I have some subfolders for documenting my different services, service A, service B. If I will go to tutorial, there is a content here. So this is the intro markdown file with some text in it. I can, again, preview that text here in my Visual Studio Code. It will render it exactly in the same way as it will be rendered on the actual website. So now we can just run from the command line npm start. And it will probably take a minute or something like that, because it will need to run the local server, it will need to build the content, and so on and so forth. And it opened it on my other monitor, which is okay, because I will just move it here. So yeah, this is how it actually look like. So I can go to service A, and this is some documentation for service A. I can go to service B, some documentation for service B here. I can go to tutorial, and you see all that navigation menus. I can go to basics. I can browse through my documentation. I can go to diagrams. Let me just collapse this guy here. I can see that Mermaid is working. And I can see that the plant UML is working as well. Just give it a minute, because it's actually calling the remote server, and that server may be on a cold start. Yes, as you can see, everything is working perfectly. I can collapse this menu. I can change the theme between black and white. As you can see, this is the white background here still, because this is an image. But if I will go to Mermaid, you can actually apply some custom CSS to your Mermaid diagrams, and yeah, they will not look so awful when you will switch the theme between dark and white. So as you can see, it was pretty easy to run it locally. And I also have a Docker file. Let me actually show you the Docker file. You can easily put this website in a Docker container. Here, I mean, like I created that maybe not according to best practices, but what I wanted to show you here, I just wanted to show you how it actually works. So you see, I start my Docker file from the Node.js image. Then I'm also installing Git here. The reason why I'm installing Git here is because there is a way how I can configure that on each and every page. It will show me who was the last person who edited this page, and he gets that information from the Git repo. So that's why I'm also installing Git here. And then if you're familiar with the Node.js, then you will see nothing out of ordinary here. I'm copying my package JSON, my package log JSON. I'm restoring my packages. I'm copying all the other files, and then I'm running the npm run build command. The npm run build command, what it will do, it will create this static Dacosaurus folder, and in this folder, it will be everything that I need to, oh, sorry, not that folder. No, sorry, I was mistaken. It will create another folder. Let me just show you npm run build. But anyway, it will create a folder, and in that folder, it will put all of the content that is a pre-rendered content for all of my documentation. And then I need the Node.js just to build it. To run it, as you can see, I'm using the good old Nginx. And what I'm doing, I'm just I created the custom Nginx config for that. But anyway, what I'm doing here, I'm just copying all of those static files to become part of my image. The reason why I use the custom Nginx config here was mostly because of one feature. Because I wanted to host my documentation because of this line, actually, line 15, because I wanted to host my documentation not on the, let's say, root path of my domain, but I wanted to host it under the docs. And I wanted my image to be able to automatically redirect all the requests that came to the root, redirect them to docs path. So this is basically it. As you can see, it's easy to work with, it's easy to run, it's easy to put in your Docker container. And if you can put it in your Docker container, then that means that now you can host it literally everywhere. Saying that, let me actually find my presentation again, and let me actually continue with the rest of the slides. So what I showed you how you can work with the Dacosaurus in one repo locally, everything works fine, and so on and so forth. But what if you have multiple services? Because what we started with originally is that we want to host the documentation for our services in the same repo where the actual service is hosted. So that will basically mean that we will need to do what? Provision like more than one instance of a Dacosaurus, and actually it is. So we ended up basically working with the approach of n+1 repos for our documentation, and it works in a way that documentation related to service, to each service that we create, stays in that service repo, but it may be some documentation that is more general or related not only to one service. In that case, we have this +1 centralized repo where we have all the remaining documentation. And the automation flow that we managed to basically make everything work is the following. So first we have the develop stage. So on a develop stage, we write the code, we write our test, and we write our documentation, and then we create a pull request. So we start with the feature, with the requirements, write code, write test documentation, and create pull request. Then we have the review stage. We review the code, we review the test, and we also review the docs. I also promised you that I will tell how the technical writers worked with us on this project. So if before the technical writers were responsible for, let's say, creating the content, so they were kind of, interviewing the engineers and so on and so forth to understand what they need to write in the documentation and so on and so forth. Now we are not doing that. We stopped doing that. And now we invite technical writer at this stage. We invite them to review the documentation that was created by the engineers. The idea here is that each engineer, as you can see, when he basically grabs a feature, when he starts working on a feature, he is responsible to create a piece of the documentation. So it's not like you need to spend, I don't know, like the next few months, if you are a developer, you need to spend the next few months just writing some documentation. No, it's not like that. You take a new feature, you develop this feature. If it somehow affects the documentation, and in 99% cases it does, then you also need to specify in that documentation what exactly was changed. And we invite technical writers as reviewers here because of the few reasons. So what we expect from them, because this review of the documentation here, it also happens in, let's say, 2 steps. So the first step is that the other person, the same person who reviews your code and your test, the same person reviews your documentation as well. And that person is responsible for checking that your documentation is technically accurate. Okay, that you will not write something that is that doesn't make sense from a technical standpoint. And the tech writers, they are invited as on a second stage as a yet another quality gateway for this documentation. So the tech writers, what they are doing, they are checking this documentation for example, that this documentation is easy to read. Does this documentation is easy to understand for a person who may not have the full understanding of the context of the application. They also help us to check everything in terms of, let's say, the quality of our English, because yeah, I mean, like, I know that my English is good, but still, I mean, like, from good to perfect, there is a big gap. So the tech writers, what we expect from them, that they will help us somehow to, like, fit that gap. And in some cases, if the documentation is not good from the English perspective, then they will also highlight that. And then we merge our pull request. We merge our pull request back to the same repo where we have our actual code of our actual service. After that, we have the documentation sync. So how we do that, we just push this documentation, we just push it to the centralized repo. Okay, so we grab all the files that are related to the documentation for this specific service, and we push that to that centralized repo. And then it starts basically another project, the publish process, sorry, when we render new content, because the content was updated. And as I was saying, we're working with the static website generator. So that basically means that we need to re-render the whole website again. Even if we added just one page, potentially we may need to re-render the whole website. The reason for that is because you also saw that there are some menus on top, there are some menus on the left side, and so on and so forth. All of those pages are pre-rendered HTML pages. So potentially we may need to re-render everything. Then we need to upload that new content, and then we need to run yet another task that I was not mentioning, but I did that on purpose. After we publish the new version of our documentation, we need to update our search index, because we also want our documentation to be searchable. So let me show you actually how it works in real life. For that one, I was also using some Microsoft technologies, but I don't know why I actually said also, probably because I'm mostly working with Microsoft-based technologies, but nonetheless. So what we will be doing now, let me actually start that in new window. Let me open, first of all, Azure DevOps. And this project here. So what I have here in my project, let me show you the repos first. I have 3 repos. I have service A, I have service B, and I have the centralized repo for my documentation. And in service A, and the same actually goes for service B as well, as you can see, I have a folder for the source code, okay? And here I have nothing, but I mean, like my source code just goes here, because I'm just ignoring this folder for the purpose of this demo. And then I have the Docusaurus folder. And here under the docs, I have service A only. If I will go to service B, then again, Docusaurus docs service B only. And this is the fully fledged Docusaurus engine here, so I can run it locally, I can edit that locally, I can basically see how it will look like locally, everything will work perfect locally. And now I have the centralized docs repo. Here I also have Docusaurus, here I have docs, here I have service A, B, and tutorial, just to show that if there is a general documentation, then it will go here. Additionally, I'm having some pipelines. Sorry if you hear some background noise, it's just my cat decided to go completely bananas, but I really hope that it will not disturb us. So this is, for example, the service A docs sync pipeline. Let me actually show you what I have inside this pipeline. So first of all, let's start with the trigger area. Okay, so as you can see, this pipeline will be triggered only when something will appear on the main branch, and only, oh, by the way, this is, oh, this was my cat. Yeah. So sorry for that. This pipeline will be triggered only if something will appear on the main branch, and only if that something will be basically a change under this path. So if something was changed not related to the documentation, that pipeline will not run. Then what we're having next? Then the first 2 steps of the pipeline are to basically download those 2 repos. So I'm checking out, I'm downloading the current local repo, this one, self, and also I'm downloading my centralized repo. Here, I'm specifying that I want to persist credentials. The reason for that is because I will be creating a commit to that repo a bit later. So what I'm doing now, because I'm a bit lazy, oh, I have a typo here. So first, as a first step, I'm removing all of the old documentation from my global repo that is related to this service A. Then I'm just running the tree command, because in a logs it will be really cool to see what exactly I have on the file system at that stage. Then I'm again running a simple command, a simple copy command, when I'm copying everything from the first repo, from that folder, service A, to the global repo, to the corresponding service A folder. Then I'm running some git commands. I'm setting the global username and the global email, just because otherwise I will be unable to create any commits. Now I'm working in my global repo only. The first git command is to create a main branch, because by default it will be disconnected. Then I'm adding all of the files to my index. Then I'm running git commit command with the message sync docs from service A, and then I'm running git push. So let me show you, I will not save that. I will fix that later. Let me show you how it works in the real life. So again, let's go to repos. Let's go to service A, okay? And here, what we will be doing, we will go to branches and we will create a new branch and we will call it demo. Okay, we will create it from the main branch. Let's say that this is a new feature that I was started working right now. Okay, now I download basically this demo branch locally. I change something which also changed the documentation. So now let me just update this. All stars is awesome, something like that. So I updated. I updated my documentation. Okay. And now I made a commit and something was changed. So it offers me to create a pull request. So I'm creating a pull request, create. So now I have this pull request. Now I can invite someone to review this pull request, and that person can go to files, can see, okay, something was changed in documentation, can review, can comment if needed. He can download this branch, run the Docusaurus locally, and do all that stuff. If we will go to our pipelines, we will see that for now, pipelines are not running, okay? So let's get back. Let's say that everything is fine here. So I want to complete this pull request and also remove those branches and so on and so forth. So I complete this merge. Okay. And yeah, it was completed. And now if I will go to pipelines, you will see that the service A pipeline is running because now I completed that pull request and the new content in a master branch appeared under that path. So let's go here. This pipeline actually runs super fast. Oh, as you can see, it's done already. Let me try to refresh it here. Yeah. And when I refresh it here, you see that now the docs publish pipeline is running as well. So the docs publish pipeline was triggered because I get some new changes from in a master branch from that other pipeline. This pipeline is also triggered on a main branch, but this pipeline triggers when something was changed in the global scope of the Docusaurus, and this pipeline will do a very, very simple stuff. Just in one task, it will build and push this image to Azure Container Registry. So what we can do now, we can go on the portal, on my Azure portal. And what we can do here, we can, first of all, I need to switch to this tenant. And on this tenant, I need to go to this resource group, and I will show you what I have in Azure, what I needed in Azure to be able to run the Docusaurus there. Okay. So first of all, I have 3 different web apps. So the Docusaurus site, I'm using this one for the Nginx. I'm using Docusaurus search to run my search index, and PlantUML to basically render my PlantUML diagrams. The reason why I'm doing that is because in that project that I was working on, and that project it was also a mandatory requirement, and I do believe that you will agree with me on that, that the documentation that we're creating, in one hand, it should be publicly accessible, but on the other hand, we were really concerned that something that someone can put into the documentation may be a data of a sensitive nature, and we may easily have a data leak if we will use some public services. because for the plant.uml, for example, you can just go to plantuml.com, and technically you are able to use their rendering service for your plant.uml diagrams. But in that case, you will need to send the whole text of the diagram to them so they can render you that picture. So that's why we hosted the plant.uml locally. And for the same reason, we also hosted the search engine locally. And we're maintaining our own search indexes because we don't want to use even any SaaS solutions that are there on the market. We don't want to use that. That's why we have it here. Then we have the app service plan. And for this app service plan, this is basically a host. It has like 2 CPUs and 3.5 gigs of RAM. It costs me around like $25. Technically, I can probably even scale it down to be 1 CPU and 175 gigs of RAM, but I decided to upscale it just for the sake of this demo. So B2B, B2C tenant, we will skip that for now. The container registry, again, this is the private container registry that we're using to store our images. The reason why I tell you that I probably didn't really implement that according to the best practices, because for each and every change in my documentation, I will need to create a new version of an image. So that's not really good, because in one hand, my images are kind of now became stateless, but on the other hand, they will update really frequently, and they will update not due to the application update, but due to the content update. But anyway, again, that was just easier for me to run the demo. You can always have a separate Nginx, and you can always have content stored on a network share, and then you can upload the content without the need to redeploy the entire Nginx image. And the other guy here, as a container instance, this guy is a scraper. So why I have it as a container instance here? Because the scraper is something that I need to push once after I've updated my content. What will happen when the scraper will run? It will grab the sitemap XML from that website, and the sitemap XML is another file that is generated by default. So it will grab sitemap XML, and it will go through all of the links, through basically all of those static pages that you have on your website, and it will update your search index with the content of those pages. So this guy here, on this small website where I have maybe like 20 pages, runs for about like 2 seconds. So it's also really fast. And the B2C tenant here is the way how I can protect my application from unauthorized access. So on one hand, I have my Nginx, and I have my static HTML files, and I don't want to develop a solution that will actually manage some access permissions for me in Azure. If I need something that will be really simple, and by really simple, I mean, let me show you why I'm trying to explain that. Let me just show you how it works. So this is my site. Let's say that I want to go to that website. This is the URL. Let me copy this URL here, paste it here. So I'm trying to go to this website. See what will happen. Oh, sorry, I was already logged in. Let me do the following: new in private window. So if I try to go here as an unauthorized user, what will happen? It will basically show this sign-in form for me. And I do have a user with some login and password, so I can sign in. And now I will be able to browse the entire website. So I can go again, tutorials, I can go diagrams, I can go mermaid. This is my mermaid diagram. It was not yet updated, probably it's just working a bit slow. And this is my plant UML diagram. So everything actually works here as expected. And talking a bit more about my Azure Active Directory B2C tenants, what I wanted to show you is that for now, I've configured it in a way that it will allow me to create some local users. But if you want, for example, to allow users from your organization, which are using the, I don't know, like Microsoft Azure Active Directory or Google accounts or something else, you can easily connect a new source, a new identity provider, for example, as I was saying, Google, Facebook, like LinkedIn, whatever, and then the users from your organization will be able to log in here. They will not need to manage different accounts. I mean, like have a separate pair of login and password just to be able to go here. So yeah, that was pretty much it that I was planned to kind of discuss with you today. And the last part, of course, is dedicated to questions. I know that I promised that this session will be 1 hour only. It happens to be 90 minutes, maybe a bit less, but anyway, I see that we lost a few guys, but maybe someone, I mean, like those who left want to discuss something, maybe have some questions, so feel free to ask them. Okay, I already see a question in the chat. How we can check documentation quality, relevance, compliance with standards automatically? Oh, this is a good question. Actually, there are a few questions here in chat, but I will start with this first part. How we can check documentation quality automatically. So unfortunately, I don't know that because, you know, different people have different views on what is the perfect documentation. So if I can get back to this slide, then from the CTO perspective, from the architect perspective, from the QA perspective, they will look at the different parts of the documentation and they will basically assess only those parts that are relevant to them. So that is why we were having this manual documentation review process. So if, for example, if QA wants to check and wants to participate in the documentation review, we can easily invite him, and yeah, he will be able to provide a feedback right away. Is this documentation good? Do we need to add something, and so on and so forth? So this is how we were handling that in terms of, I mean, like in terms of text and diagrams, because the next part of the question that I see here is it possible to integrate test coverage check into CI pipelines? So technically, yes. I mean, like you can do that. And what you can do, for example, I was not showing that here, but that's a really good question. Let me see if I have, yeah. So I've just opened this pull request. So the idea here that in this pull request, what you can do, you can also integrate a pipeline, maybe one, maybe more. It's all up to you. You can integrate those pipelines that will need to run and that will need to pass if you want this pull request to be, you know, like processed further. So the usual flow may look the following. You create your pull request. Then, first of all, we are trying to build your application, because if your application is unable to build, then there is no reason at all for us to go any further into the review process. So we try to build it. We may want to run some unit tests. We may want to measure, as you mentioned yourself, the code coverage. We may want to run any other automation checks that we need. Even that was in actually only one of the projects that I was working with, but at that project we went so crazy that we were creating, and for each and every pull request, we were creating a new environment on demand. We deploy our application there, and we even run some other tests like an end-to-end integration test, like penetration tests, and so on and so forth. So yeah, all that stuff is possible. What I was showing to you here, I was showing only that part that is related to documentation, to the text, I mean documentation. Yeah, and is there any tools to do that for the documentation? So in my case, I'm not sure about that. I'm not sure that there are any tools that can help you with that. And the reason for that is quite simple, because when you are working with the free form text, there are no ways how you can assess it. I do believe that probably the only one quality gateway that I can imagine here, but again, this is more about, like me thinking loud right now, is that we can try to integrate maybe something like Grammarly API or whatever to our pipeline to check the quality of English in general. But that's probably it. But yeah, I really like that question. Thank you for that.
Nice.
Okay,
nice.
I hope I
Anton,
answered
I
that
was
one.
asking about those $20. It's for months, correct?
Mm-hmm. Yeah, $25. It's for the whole month, and let me just show you. Let me just show you the reason why I decided to upscale to $25, because I upscaled just basically a few hours before the demo. So let me just add. So, and for example, last 4 hours, apply. See? So here, at this point, this machine was running on one CPU and almost 2 gigs of RAM. And I was a bit unhappy because the average memory load was around 80% here. So that is why I upscaled it to be 2 CPUs and 3.5 gigs of RAM. So the memory pressure went down. Now it's around like 45-ish%. But as you can see, for the CPU, there are some spikes, but this application is no CPU consuming at all.
Nice.
Okay, so what we also have in the chat. So Mr. Dmitro said, I believe documentation should not be separated from your code. Yes, this is true. This is what we were doing. Probably I want to explicitly specify also the following. So there are a lot of ways how you can actually document your solution. If we're creating the web API, we know about the Open Web API standard, and we know about the Swagger as the tool who help us to generate this nice and fancy API documentation pages. And this is actually a perfectly good example, because feel free to continue using Swagger. Feel free to use, for example, if you're working with the .NET, then you know that you can use this XML-based comments on top of your methods to add some additional information to those APIs. I mean, like, that works perfectly fine. But still, it's not the entire documentation that I'm looking for from your service. If you create a service, what will be interesting for me to understand about the service, but again, this is the architecture point of view on that, it will be really interesting for me to understand, do you know, first of all, who are your, let's say, data sources? So if you're communicating with other services, then with which exact services are communicating, so from which services you grab some data. And the second question, to which services then you send that data. So I want you to know, and I want to have that in your documentation. So you will explicitly tell me, okay, this is my data sources, those are my consumers. And that kind of documentation, you cannot put that in Swagger. So Swagger is a good tool, but it's a different view. Swagger is extremely cool for developers, for the QAs, and so on and so forth. But for the architect, I'm more interested in another kind of an information.
Mhm.
So next, again, Mr. Jürgen, but how can we be sure that our repos are synced if we can commit to the general repo manually? Yes. So this is the point here. We should not commit to general repo manually. We can use a bunch of different techniques that can prevent us from doing that, or at least we can use some techniques that will prevent us from changing those exact folders for service A, service B, and so on and so forth. So for example, if I'm working with the docs centralized repo, if I will put something under this service A or service B folder, if I will put that into the docs repo directly, then according to my pipeline, the next time the changes will came from the actual service A or service B, my changes that I made here, they will be removed and they will be lost forever. But still, I have this tutorial area and I can modify the tutorial area, and it's perfectly fine because no one will override that. So what we were doing, we were just establishing a set of policies to prohibit the direct modification of those service A and service B folder, but still allow the modification of the tutorial folder, the modification of other files, and so on and so forth. The next question is how we can create some tree structure for our documentation, like chapters, articles, and so on and so forth. Good question. The idea of the Docosaurus is that it will mimic your actual file system structure. So again, I will use the tutorial area as an example. So see, under the tutorial, I have diagrams, I have basics, I have extras, and then I have some files inside. If I will go to my website, then I have tutorial, I have basics, I have diagrams, I have extras, and so on and so forth. So it will mimic that in that way. So if you see that on a file system, technically you can still change with some meta tags the URL for those pages, but the default rule is that it will mimic the file system, and you can create nested folders and so on and so forth. It will work perfectly. As for tags, I'm not sure that you can use something like tags. I mean, like we didn't try that. But the idea here is that you have your search box and you can search something and then you can navigate from your search box to that page. So we were just managing that. We were just managing this like that. In our case, we were working with the team of about like 200-ish engineers, and they were working on I don't remember exactly how many teams, but maybe about like something like 15, again, different teams. And across those 15 different teams, it was, I don't remember, like a few dozens of services. And this was the approach that worked for us fine.
It should be okay.
Cool.
One more thing.
Mm-hmm.
Full text search or some like big amount of text search. Like if we have a lot of documentation, can we optimize it somehow, or how fast will be that search? You know?
So to be honest, so technically what you can do, you can create your own plugin for full text search, but I'm just using one of the open source tools to do that because everything is integrated there. Let me just do the following. If I will go to my storage account, here I can go to file shares and I have the file share search. Oh, no, let me actually, let me take it one step back. So I have this search file share, and this file share is used only for that search index. What I want to do here, I want to go for properties, if I'm not mistaken. And as you can see, now it's half of the megabyte. So for those kind of 20-ish pages, it's half of the megabyte. It's so small, but you can also go and check the content. You have database that have some logs. I don't know actually what is the exact format. You have some archive data as well. Because again, as I was saying, this is the open source tool. I run this tool in Docker container, and because that Docker container is stateless, I'm also mounting my storage to it so that tool can store those search indexes. And I was trying that on a bigger website. I was trying that on a website when it was about like up to 1,000 pages or something like that. And I was pretty happy with the performance actually, because I get my responses much faster than from the Confluence. I do believe anything will be faster than the Confluence. But anyway, I get my responses in less than 1 second. Another important actually thing to notice here is that even if you will create this structure, even if you will put, as I did, that Azure Active Directory authentication in front of your app, still you will have one centralized place where you will have all your docs. It has pros and cons, but for me, I actually like it that way, and I like it that way because another pain point from the Confluence that I experienced is that if you're working with the Confluence, you are when you're trying to search something, okay, you're searching, and then Confluence can reply to you something like, we were unable to find any pages. And technically, it doesn't give you the full understanding why that happened. It may be because there are no content on that topic, or it may be because you don't have access to that content. So in this case, everything is available for kind of everyone, and if you search it here and if you're not finding it here, then it's not existing.
Okay.
Okay, so we do have one more comment. Let me just try to check what at that comment. The commenting is considered unnecessary if one can move further, avoiding it. Yes, on that statement, I agree. The process should be inescapable. Ooh, this is a good one. Probably I will agree to that statement as well, because yeah, we found that the lack of the documentation really costs us a lot in terms of synchronizing the knowledge across the team. So as I was saying at the beginning, we basically made this documentation a part of our definition of done. Like no one likes pairing separate time to physical activities. Yes, but if community work, yes, exactly. Yeah, I totally agree with what Pandmitro was saying in the chat. Okay, so it's mostly me and you, and
yeah. So Anton, may I ask you to open a link in the chat?
Yes, let me do that. Yes, I will do that in a moment. I just need to do some copy and paste and activities because the chat is not cooperating with me.
I see Anton is planning to buy a new car.
Yeah.
Okay.
I will also accept the cookies.
Okay, so first of all, I want to thank All Stars IT for organizing this event, for spreading the news and allowing us to learn something new. Actually, I was aware of some things that Anton has mentioned, but to be honest, he added a lot of base over what I knew. And actually, I want to check a lot of things and try it with my projects. Like Anton, you're the best. But All Stars IT organized the event. We invited Anton to tell us something interesting, and actually there were a lot of requests to hear about documentation and automation of this process. And I think more people will learn about this topic on YouTube. So, by the way, we are making the recording, so you'll be able to review it, to watch it again. So, and if you want more events like this, like you may follow All Stars IT in all the social media like Facebook, LinkedIn, Instagram. I think we have TikTok accounts. So Telegram, anything, like what is more convenient for you, because we have monthly meetups, monthly trainings, workshops, different initiatives. So pay attention. Plus, as you may see, we are on a career page. I think we have so many nice vacancies, and like those are mostly Israeli projects with high salary, very high salary. And plus, All Stars IT is actually best place to work in 2021. And as I know, according to Dow, we are top one in our category during this year. So it's a very good place to work. Like there are a lot of events, there are a lot of training activity, learning programs like L&D initiatives, plus companies very supportive. Like you'll get a lot of benefits, you'll get a lot of travel opportunities if you want, or you may just stay somewhere in mountains and work remotely, no pressure at all. Like a lot of people who work for us think it's very convenient. Anton, you may also think about joining us because we are looking for the best, and you are definitely the best. Thanks a lot for giving us this honor. And I do learn a lot today. And I don't want to rewatch your presentation, but I will definitely check for some technologies that you have mentioned. I did some notes as well. And thanks a lot. Thanks a lot. I always enjoy seeing you and taking part in your workshops, in your meetups that you conduct. At the end, I want to thank everyone who has joined us today, and to thank everyone who will watch us or watching now in recording. Thanks a lot. Let's keep in touch and see you later. Take care.
Thanks for having me here. Have fun, guys. Bye.
Have a good evening. Bye.